Good morning, good afternoon, good evening. This is the Revision News. We now cross over live to our waterfalls correspondent, Bill Gates. Bill. Hi everyone, you asked for visual learning. Here is the waterfall, literally right here, look. So up there, river's carving away at that landscape, forcing the water down here through gravity, and it falls down here into the plunge pool. Now rocks will fall down from here over time. Most of the time it is just water though. And trust me, it's quite wet. Whoa, so really refreshing. Thank you for that very insightful and very wet report there, Bill. Over to Milo now with the waves report. Milo. Thank you, Clive. And yes, I'm reporting live from a beach in South Thailand. You can see that this beach is very important for tourism, primarily because of the people here. You can see that there's loads of different people using the area for sports events, for hotels, restaurants, bars, etc., bringing money to the local economy. Now, that means this beach needs protecting, but Thailand's not a rich country. Can you see any sea walls? I can't either. Can you see any groins in that water there or there? No, that is a pier, not a groin. So, no, you can't. What there is, however, is limited access to these kind of things to protect the area from flooding. Right in the corner you can see rock armour, right in the distance, but probably nearer you can see a lot of these trees. Now the odds are that this was here before, this was a beach for tourists, but the fact is they've got a lot of plantations and stuff that can absorb the water should it go over that way. That means the flooding is not prevented, but it is certainly less likely. And that makes the area more profitable for tourism, especially for the long term. It's more sustainable. So yeah, you can see the waves here. At the moment they look like they are destructive because they seem to be taking sand away and sediment away back out. You can see down here all the sand and sediment go back out into the water. It's a destructive wave. If they were constructive, they'd be dropping the sediment on here, which clearly has happened. Back to the studio. Careful of those jellyfish, Milo. They'll get you. We now have Aiden. Aiden is actually live in the small-scale ecosystem. What's the situation there, Aiden? Thank you for that smooth changeover. Yes, we are now here at a local ecosystem. And it's not the one you studied. Obviously, this is not Epping Forest. This is not your case study for a local ecosystem. That's more like the UK. But this right here is definitely a local ecosystem. You can see the trees, you can see lots of animals. Maybe not with a camera, but loads of dragonflies. These holes in the ground, they are for crabs. There's fish in there and all sorts of bacteria and insects too. This is a local ecosystem because it's small, it's localized. It's not big, it's not like a massive biome. It doesn't cover the majority of a continent. This is just one example within a larger biome. So the ecosystem, this ecosystem here is more like a jungle. But this small scale ecosystem has lots of decomposers that will break down these leaves over here on the floor, the litter down here. That'll get broken down over time by decomposers, and those nutrients from these will go into the soil, eventually giving the soil a little bit more nutrients to grow, for example, this tree, or 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 this tree. You're also going to have primary consumers, you're going to have secondary consumers, tertiary consumers, things that eat other things. Lots of examples of food chains and food webs around here. For example, I presume there'll be a little fly there that gets eaten by a bigger spider that might get eaten by like one of those little lizard geckos you get around here in Thailand. There's evidence all around you of small-scale ecosystems, and this is just one of them. Small pond, birds, insects, and all sorts. Back to the studio. Finally on tonight's news channel, we have David. David, I hear you're by a rainforest tree. Is that correct? Can you confirm, David? Can you hear me? Yes, thank you for that smooth changeover. You're drawing me live in the jungle, and you can see evidence all around you of adaptations from plants and animals. Well, the animals is harder to see. So you have animals through here that will be camouflaged. You can't see many animals, but they'll be camouflaged in there. Obviously, the ones you studied about would be the sloth, and there is no sloth that I can see here, but they have large claws to hang in the trees. They also have camouflage fur and algae on their fur to make sure they're not spotted by predators. They can also hang above the trees to stay away from predators like snakes on the ground. But here you can actually see some evidence of what you have been studying. So here, this for example, this right here has a drip tip. Okay, right there. So over time, as rain falls down on the leaf here, it will eventually run off. Now that's important off the end of the tip there. That's important because it means the water doesn't get stuck on the leaf, which also means that algae can't grow on the leaf and block it from getting sunlight, i.e. that sun. But also, it means that the water gets down to the roots below. Speaking of roots, I can't quite see many here like you will have studied in the Amazon, but look at some of the roots down here. Now you'd imagine they are pretty big to get all access to that water that is needed. The similar case of buttress roots. So buttress roots, don't forget, go into the ground really, really far in the rainforest. This is a similar rainforest biome, by the way. They go right down to get as much water as possible, much nutrients as possible from the poor quality soil. Why is the soil poor quality in the rainforest, I hear you ask? Well, I'm hoping you know that already. I'll give you a minute to try and think about it. Nutrients are poor in the rainforest, even though there's so many trees, because there's so many trees. Imagine there being 10 boxes of pizza. Lots of nutrients in there, but then you have 1,000 people eating them. You're not going to get much at all. It's the same case here. There's not many nutrients here for the trees to get because there's so many trees taking in the nutrients. So many trees taking in that nutrients. All those big roots down there you can see. Now what you're going to get from that is lots of litter on the floor, like this thing here. Lots of litter there. And that will eventually decompose, like in the small scale ecosystem. So that's a little bit about the adaptations that plants and animals can take. You've also got the frogs that can change colour in terms of showing danger to try and prevent predators from eating them. You've also learnt about emergent trees that can reach very high, like those up there, to make sure to get enough sunlight, because again, there's lots of competition. Back to the studio. That's all for today with the revision news. Stay revising.